Good morning, grade 12s. Here we go with the second lesson in the post-COVID MDM4U course. So when you're looking to do your major project, you want two variables and you're looking for your X to have an influence and change your Y variable. Example, school board may want to use calculators. They want to know if the investment in calculators is worthwhile. So they do a study to see student learning with and without calculators, or the number of calculators per class, and see what happens to the marks. Strong correlation does not prove one variable causes the other. You got to be very careful with that, and make sure in your major projects you're not using the word prove. You're not proving anything. You're supporting your hypothesis, which is your educated guess, and supporting the idea, but you're not necessarily proving anything, because it takes a lot of studies over a long period of time to prove something, but you can definitely provide evidence to suggest something's happening. And the idea here, it doesn't necessarily mean there's causation, so one thing isn't necessarily causing the other, it just is correlated, or there's an influence. And oftentimes there's a third variable that's influencing both the variables you're studying, and that might be the causation. So you got to be very careful with that situation. And an example to demonstrate kind of how strange and hilarious some of the math can be is called Tyler Given's Spurious Correlations, and he's got a book out now of these hilarious correlations. The first one, the US spending on science, space, and technology correlates with suicides by hanging, strangulation, and suffocation, with an alarming correlation level. R level 0.99. So strong correlation there. Number of people who drown by falling into a pool correlates with Nicolas Cage films that he's appeared in that year. Per capita cheese consumption and the number of people who died by becoming tangled in their bed sheets. And divorce rate in Maine versus per capita consumption of margarine. So as you can see, correlation does not mean causation, and you got to be very, very careful when you're doing your major project. And don't use the word prove. All right, so let's take a look at the types of causal relationships that we might see in this course. So the first one is simple cause and effect relationship, where X produces a change in Y. Increasing the height from which you drop an object increases its impact velocity. Increasing the speed of production line increases the number of items produced. Driving and increasing your speed is going to increase the distance you travel. Okay, so often a lot of physics relationships, definite cause and effect. Common cause factor, an external variable causes both variables to change in the same way. A town finds that drowning deaths increase as popsicle sales increase. While the common cause there is actually hot weather, causing both variables to increase. So popsicle sales are not causing drownings, and drownings aren't causing popsicle sales. Hot weather is doing both. So the reverse cause and effect, where you initially thought one variable was changing the other, but in reality, it's reversed. The other variable is actually changing the initial variable you thought. So example, researcher finds a positive linear correlation between the amount of coffee consumed by a group of medical students and their levels of anxiety. In reality, he finds that nervous people are more likely to drink coffee. So the coffee is not causing anxiety and nervousness, but rather the nervous people are more likely to drink the coffee. So reverse cause and effect. Accidental relationship. Correlation exists without any causal relationship. For example, the number of females enrolled in engineering programs and the number of reality shows on TV both increase for several years, but that's an entirely accidental or coincidental relationship. And We looked at a bunch of those with the spurious correlations. So you've got an idea of what that looks like. Next, we have the presumed relationship. A correlation does not seem to be accidental, even though no cause and effect or no common cause factor is apparent. So you have a very sound assumption that it's presumed or there's a relationship there, but you don't have that solid cause and effect. So example, seems logical, a fit person might prefer action movies, but it would be more difficult to find a common cause or prove that one variable actually affects the other. So it's a presumed relationship that the more you are active, the more you like action movies, but there's no cause and effect there. It's just a presumed relationship. And oftentimes that's the type that you're going to be finding. All right, example 1. Classify the causal relationship in the following situations. The rate of a chemical reaction increases with temperature. So that's from chemistry. It is a cause and effect relationship because as temperature increases, the rate of reactions increases. Scatter plot of the number of storks in Oldenburg, Germany, plotted against the population of the town shows a strong positive correlation. So the number of storks against population of the town shows a strong positive correlation. As the storks increase, the population of Oldenburg, Germany increases. And if you remember from nursery rhymes, the storks are the ones that carry babies to their parents. So is that what's happening here? Probably not. A reverse cause and effect. It turns out that storks nest on house chimneys. With more people and more houses, you get more nesting sites and more storks. So that's what's actually happening, reverse cause and effect. An increase in the number of students enrolled in data management and an increase in the number of BMWs on the road. So is the increase in the data management enrollment a result of more BMWs on the road, a reverse cause and effect? No, that's not what's happening. What's actually happening is a completely accidental relationship. It just happens that more BMWs are on the road and more people are in data management. Coincidental, there is no causal relationship. There's no reverse causal relationship. It's just coincidence. Price of butter and motorcycles have a strong positive correlation over many years. And is the price of butter causing motorcycles to go up in price? No, it's actually a common cause. It's a thing called inflation. Inflation has caused parallel increases in the prices of both items over the years. Heart attack rate drops as fitness clubs bring in more revenue. So as fitness clubs make more money, heart attack rates are going down. People must be exercising more. Is that causing the decrease in heart attacks? Probably. So a presumed relationship. A negative correlation seems logical here. However, there's no apparent common cause factor or a cause and effect. We think that's what's happening, and there's no direct causal. In your major project, you're going to determine the nature of the causal relationship. And oftentimes it can be complicated by extraneous or other variables that you didn't consider. So in your major project, keep that in mind. That's why I mentioned to you that the more you know about your topic, the better for your project, because you'll be able to identify some of these extraneous variables easier and at least try to account for it. Oftentimes with your initial idea, you might not find a correlation, even though you think there should be one, because oftentimes these extraneous variables are muddying the waters and complicating the situation. So for you, keep that in mind, and the more you know about your topic, the better. So example here, you might see a strong positive correlation between term marks and final exam marks for students. Extraneous factors could affect exam results, such as how much studying a student did, exam schedule, ability to work under pressure, anything else that happened in their life leading up to that exam that complicated it. Maybe they got sick, etc. Obviously, typically you do well in the course, you do well in the exam, but that's not always the case. So there are other factors complicating the waters. Suggested exercise, page 399, 1 to 7, 10, and 12. And this is lesson number 2 of post